So, today we're going to talk about transformations. The idea is to take a fairly basic shape and then to use that shape to help us draw some other pictures. For example, think about what the basic parabola looks like. This is just the function y equals x squared. For our sake, we're going to start writing it out like this. We'll say f of x equals x squared. And we're going to take this picture and do all kinds of things to it to make it into another function. We will push it up, we will push it down, left, right, we will stretch it out, we will compress it. We're going to find multiple ways to take this picture and to generate a ton of different pictures from this. The first type of transformation we're going to talk about are static transformations. These types of transformations don't actually change the shape of the picture, it just picks it up and moves it around. So, for example, if I gave you some function f of x, then the function f of x plus a will move this function up by a spots. So in our example, if we had f of x equals x squared, then let's consider what happens if we look at the function f of x plus 2, right? Which will mean this is the function x squared plus 2. All we're going to do is we're going to take this picture and we're going to push everything up by 2 points. So for instance, here is the vertex 0, 0. It's going to get bumped up to here, 0, 2. Okay? This is the point 1, 1 right there. We're going to bump that up to the point 1, 3. Right? And we can do the same thing with a bunch of these other points too. But it's going to take this parabola and it's going to push it upwards like this. Okay? So we literally just picked the whole thing up and pushed it up by 2 spots. Right? So the mathematical operation that we're doing here is we are adding 2 to every y point. So that point 0, 0, when I added 2 to the y value, it got bumped up to 0, 2. The point 1, 1, when we added 2 to the y value, it became 1, 3. So that static transformation will just take our picture and push it up by a spots. Right? So that's what f of x plus a looks like. Let's see what's going to happen when we start subtracting numbers. Okay, so here's our function again. F of x equals x squared. Let's change this around a little bit and make this f of x equals x squared minus 1. Okay. Now, whenever you have some function f of x minus a, what that does is it lowers the graph by a units. Right? And the mathematical operation that we're doing here is we are subtracting that number a from each y value. Okay. So the point 0, 0, that will then get moved down to 0, negative 1. Right. The point 1, 1 will get moved down to 1, 0. The point negative 2, comma 4 will get moved down to negative 2, comma 3. Okay. So this point 0, 0 gets moved down here. This point 1, 1 gets moved down to there. This point negative 2, 4 gets moved down here to negative 2, 3. Right? So now our parabola looks something like this. Okay? So we literally took each point and we dropped it down by 1 unit, like this. Okay? So that's f of x minus a. And what you might want to notice is that in general, whenever we have some function f of x and we add or subtract some number from it, what we're doing is we are affecting the y values. And for all these transformations, if we're doing something on the outside of the function, then we're affecting the y values, as opposed to where if we are doing something on the inside of the function, for instance, maybe f of x minus 3, or perhaps f of x plus 1, right? If these changes are occurring inside of my function instead of outside my function, then those will affect the x values on my graph. So let's take a look at our basic parabola again. If I'm going to shift it to the left and to the right, I need to affect the x values here. So if this is f of x equals x squared, then what is f of x minus 3 going to do to my function? Or maybe f of x minus 1? Well, if we're doing something inside the function like this, remember this affects the x values. And what's odd is that this does the opposite of what you think it would do. Nice spelling on my part there. So if you think about this f of x minus 1, it looks like we're changing the x values by reducing it by 1. But since it's on the inside of my function, it does the opposite of what you think it's going to do. Right? So I'm going to affect my x values by adding 1 to each x value. So this point right there, that is 0, 0, that's going to get shifted over here to the point 1, 0. Okay. This point 1, 1 that's on my graph, that's going to get shifted over here to the point 2, 1. And this point negative 1, 1 right there, that's going to get shifted over here to that point 0, 1. And then I can sketch my parabola like this. Okay. All right, so in general, these types of transformations are going to take this form. F of x minus a or f of x plus a. Right? What will happen is that this particular transformation will shift my function to the right by a units. Right? And the way we do that is, is we add a to the x value, and f of x plus a will shift the function left by a units. And what we're going to do with that mathematical operation is we will subtract that value a from the x value. So if I have some function f of x, and f of x has the point 6, 8 on it, right, then what is f of x minus 3 going to do to that point? Well, this will take that point and shift it 3 units to the right. And the way we're going to handle that is we'll just add 3 to the x value. So that becomes 9, 8. Similarly, if I had the function f of x plus 2, and I was using that point 6, 8 to begin with again, then what this x plus 2 will do is it will shift the point left by 2 units. So this point 6, 8 will get moved to the point 4, 8. All right, so let's practice a few more of these things. If I gave you this particular function, f of x, and how about the function 10, 14 is on that function? Where will f of x plus 7 go? Well, that tells me to shift it 7 units to the left, so that becomes 314. Okay. What about f of x minus 2? I'll shift that point 2 to the right, which would make it 1214. What about f of x plus 3? Well, since it's on the outside now, not on the inside, what we need to do is add that to the y value. So 1014 becomes 1017. Right? And f of x minus 5, that'll take that point 1014 and drop it down to 109. Right? And we can mix and match these things as well. What about f of x minus 5 plus 12? Well, what that is going to do is that says to shift it 5 to the right, and that says to shift it up by 12. Right? So this point 1014 is going to get shifted 5 to the right, which will put me at 1514, and then it's going to be shifted up 12, which will put me at 1526. All right, these types of transformations are called static transformations. And again, what that means is it changes the location of our graph, but it doesn't change the shape of the graph. Let's go ahead and talk about some non-static transformations while we're here. These types of transformations look like this. Assume we're given, again, just some function f of x. Right? How about the function f of x equals the square root of x? This is just my square root function, and it looks a little bit like this thing. So what I'm going to do now is I'm going to start stretching and compressing this thing horizontally. That's actually a mixture of two words, horizontally and vertically. So let's look at it vertically first of all. So if we're going to stretch something vertically, we're talking about the y values, which means we have to do something on the outside of the function. So what I'm going to do is I'm going to take this function f of x, and I'm going to multiply it by some constant, let's call it a. What happens here is two things. First of all, if a is bigger than 1, then this stretches the function vertically. In other words, it'll make it bigger. Right? So, for example, this point 4,2, if I have this particular function, f of x equals 2 times the square root of x, what I'm going to do is I am going to multiply the y value by a, whatever number that happens to be. So in this particular problem, this point 4,2, I will multiply the y value by 2, so 4,2 will get stretched out to the point 4,4. So 4,2 becomes 4,4, right up there. Of course, the point 0, 0, if you multiply that y value by 2, you're still going to get 0, 0. So I've still got this particular point sitting there as well. Right? The point 9, 3, if I multiply that y value by 2, it'll jump up to 9, 6. So that 9, 3 is going to jump up to here someplace. So this square root function is now going to have this particular shape to it. Right? So what I did was I took each of these points and I stretched them out to these new values there. Right? So if I multiply the function by a number on the outside, and that number is bigger than 1, I'm going to affect the y values by that multiple of a. All right, the next thing is, remember we have this function y equals f of x, right? What happens if I multiply by some number on the outside here? If that number is bigger than 1, it's stretching it. But what if that number is between 0 and 1? Right? Well, what's going to happen is when we multiply our y value by that, it's going to actually make it smaller. Right? Then we're going to be compressing this function. So for example, let's say I have the function y equals 1/3 times f of x. Okay? Remember what we're doing with our operation. We're still multiplying y by that value a. So I'm going to be multiplying each of these y values by 1/3. Right? So that point 0, 0, if you multiply 0 by a third, it's going to get mapped onto, well, still 0, 0. So I've still got that point 0, 0 right there. The point 4, 2, when you multiply the y value by a third, you'll get the function, or the point, 4 comma 1/3. So let me go over here, 2/3. So let me go over here to 4 and down to about 2/3 maybe. And then the point 9 comma 3, multiply that y value by a third, gives me the point 9, 1. So I'll go over here to 9, up to 1, and I've got that point. And it looks like my function has kind of this shape to it now. So again, I took each of these values, each of these points, and I compressed them by a factor of 1/3. Okay. So to review, if I gave you this function a times f of x, multiplying by some number on the outside, what you're doing is you are multiplying the y value by that number. Okay. And if that number is bigger than 1, it stretches it. If that number is between 0 and 1, you're compressing it. And if that number actually equals 1, then you just have the exact same function anyway, so that's no big deal. And even if it's a negative number, it's not that big a deal either. You can still multiply through by that negative number, and it'll still work. So let's take a quick look at that. So here's our square root function again. Right? So I have f of x equal the square root of x here. Right? What if I had negative 2 times f of x? Right? Well, again, think about what's going to happen to our points. 0, 0, multiply that 0 by the negative 2, doesn't change anything. Right? The point 4, 2, that's going to get mapped onto 4 comma negative 4, right? After we multiply that by a negative 2. And then 9, 3, that's going to get mapped onto 9 comma negative 6. Okay? So we've got these points 0, 0, 4, negative 4, and then 9, negative 6. Right? So it looks like I've got this particular function like this. Right? So when you look at this, the negative 2 part of it stretched it, and the negative part flipped it about my axis like that. But if you just recognize where all these points go, it shouldn't be that big of a deal. Okay. Let's look at one more non-static transformation. All right, so this type of transformation actually goes inside with the x's, right? So if I told you that f of x equals the square root of x, what happens if I put that number on the inside and make it f of 2x? What is that going to do? Right? Well, in general, here's what happens. If I had f of, let's say, a times x, right? Since it's inside with the x's, it's going to affect my x values. But remember, it does the opposite of what you think it would do. So here, since I'm multiplying x by that number a, what's actually going to happen is we're going to wind up dividing each x value by that number a. So for f of x equals 2x, f of 2x, what I'm going to do is I'm going to take that first point, 0, 0, and I will divide the x value, in this case, by 2, which will still give me 0, 0. Right? And the point 4 comma 2, well, when I divide that x value by 2, it's going to go to 2, 2. And then the third point on there, 9, 3, it's going to get divided by 2 to give me 9 over 2 comma 3. So these 3 points, 0, 0 is not going to get changed. 4, 2 is going to get pushed here to 2, 2. And 9, 3 is going to get pushed here to 9 over 2 comma 3, or 4.5. Right? So it's going to look like this. And what happened is, since we made those x values smaller, it actually pushed them closer to the y-axis like this. So we are compressing them that way, in that direction. So these types of actions are called a horizontal compression. Okay. So what do you think is going to happen if we multiply on the inside by a number between 0 and 1? Let's take a quick look. So in this case, what if I had f of x equals the square root of x, and I want f of 1/3 x. Well, remember, the process is still going to be the same. I'm still going to divide every x value by that number. In this case, it's 1/3. So that point 0, 0, I will take the x value and divide it by 1/3. And if you remember, dividing by 1/3 is the same thing as multiplying by 3. So that'll still give me 0, 0. The point 4, 2, if I divide 4 by 1/3, same as multiplying it by 3, gives me a 12. And the point 9, 3, if you divide that by 1/3, you get 27, 3. So here are my 3 points. 0, 0, 12, 2, and yeah, 27, 3 is way out here someplace, right? So it's going to look something like this. So again, what I'm doing is I'm taking each of these values and I am stretching them along the x-axis to its new point way out there somewhere. All right, so here are the types of transformations we can have. Right? We can have the static ones, which is f of x plus a, right, which moves my function up by a units. F of x minus a, which takes my picture and just pushes it down by a units. Right? We also have this static transformation of f of x plus a. Right? Remember, that moves it to the left by a units, and f of x minus a moves it to the right by a units. Right? Those are the those are the static ones because those do not change the shape of the graph. Okay? The ones that do change the shape of the graph look a little bit like this, right? What about f of a times x? Right? Well, it depends on that number a, right? If a is bigger than 1, then we compress it by dividing each x value by a. If I have f of a times x where a is between 0 and 1, then we stretch the function. If we multiply on the outside, remember I'm affecting my y values. So if I had a times f of x, right? If a is bigger than 1, then this is a horizontal stretch. And if a is between 0 and 1, this becomes a horizontal compression. Right? So again, if it's on the inside with the x's, remember these go along the x-axis, so we're talking about, well, I'm just kidding, I messed that up. These are horizontal, and we're affecting the y's. The y's go up and down, so these are vertical stretches and compressions. My bad. So again, with the x-axis, we're talking about horizontals, and y-axis, we're going up and down, so we're talking about verticals. Okay? All right, so that concludes part 1. I'm going to do part 2 here in just a moment, just so we can try to combine a whole bunch of these ideas together. Thanks a bunch, and I will see you in just a minute.